For rigs to be able to drill wells efficiently, they have to be properly stationed, and they have to be able to be held firm at where they are operating. In today's video, we'll be looking at methods at which we maintain station keeping of the rigs at a particular location. Do not forget that we are speaking about floaters. For bottom supported rigs or rigs that sit on bottom, we will not have to look for a way to keep them stationed. As we discuss, please do not forget to like, subscribe, and turn on the notification button. So moving right straight into it, there are various rig movements that can affect a floating rig. So we have the pitch, we have the yaw, we have the roll, we have the sway, and we have the heave. And because of these movements, we have to look for ways to ensure that our rig doesn't move off the location. Because if that happens and that happens continually, it prevents, I mean, it reduces the efficiency of us being able to drill our wells. So, there are there are two basic methods at which we can position the rig on location. One is the spread mooring, where we have anchors, we have lines from the rig, anchors all the way to the seabed, anchors on lines on this, and we have anchors thrown on the seabed, anchoring the rig, putting it in position. Then the line goes all the way to surface, and it's spread moored in such a way that from every direction that the rig will be moving, it keeps it stationed. Then the second method, that's dynamic positioning system, where the thrusters, where we have thrusters on the rig, ensuring that in whatever direction that the rig moves, these thrusters get it back to location. Of course, there will be a communication system on the rig, transducers and transponders that will be communicating to the rig to tell the rig that we are moving off location, and we are we really do have to get back on location. So it is when that information is passed through to and fro, that is when the thrusters respond to get the rig back on location. So those are the methods that we'll be looking at today quickly. So moving straight into the topic, we can see this is the diagram of what um, the forces on a vessel looks like. So you have your wind, you have your waves, and you have your current acting on this vessel. And with all those forces, it produces all these movements, like I spoke in the beginning of the presentation. And because of that, you want to use the DPS. This is using the DPS system that has the thrusters to get your azimuthal thruster, your tunnel thruster, etc to get the rig stationed. Then if you have to use the anchor, this is what it looks like. You have your fair lead, your connectors, you have your tri plates, you have all the lines connected, you clump width to ensure that the anchor chain sits on bottom. Then you have your anchor in the seabed connected to the shackle, holding onto the wire, ensuring that the rig is kept on location. So moving right to the first one, spread mooring. I'll attempt to just break it down and explain a little bit. So we can anchor the semi drill ship and tender, and before that is done, some survey needs to be done. So we have to go survey do a seabed survey. Doing that seabed survey will tell us the anchor lines that we need, the length, what kind of the quantity of chain, quantity of cable that we'll be needing, the anchor type that we'll be needing. Do we need to um, deploy special anchors for the operation? The seabed bottom survey also will give us the information on the sediment thickness, how cohesive it is, as in, do we drop an anchor in there and when we pull test, it comes with the as in it's not so cohesive that anchors can get in and stay in. Is it loose? Do we have loose sediments there? So depending on the kind of sediment, that's what's going to tell us the kind of anchor that we're going to be picking. So if the formation is loose, that means we have to get anchors that will be very deep penetrating, so that it travels much more deeper, and so that when we pull test, it gives us that firm hold that we need. Is it a, a bed that the sediments are cohesive, that we might not be needing deep penetrating anchors that to keep us on location. So again, you have to look at the statistical weather conditions to confirm how often the wind is, the direction, the speed, and and conditions. For the sea, you have to look at the maximum waves, the swell, and in what directions that they come. So when you have all this piece of information, that's what's going to help you design and rather choose equipment and design your mooring pattern that will help ensure that your rig is kept stable in that environment. So, to the right, these are the mooring methods that we have. So we have the eight line, we have the symmetric eight line, we have the 45-95 eight line, we have the symmetric nine lines, you have 45-90 10 lines, you have the symmetric 10 line, you have the skew pattern. So these are different methods at which we can moor our rigs. And all this or whatever decision that you make comes from looking at the weather survey and looking at the seabed survey, because when you're able to have that all this information in your hands, the design gives you an efficient method on how you can position your rig on location without issues. These are types of anchors that we can use here. You can see the step pre anchors. I've used this quite a lot of times. You have your Bruce here, you have the Bruce anchor. So these are different types of patented anchors that can be used to put your rig on location. So, like I said in the beginning, the condition of the seabed sediments will advise you on which of these anchors to pick. Because if you don't do that survey, there are no guarantees that the kind of anchor that you're going to be that you I mean that you've pretty much chosen on a whim is going to be efficient and where keeping you stable and well anchored where you need to be. So you have to do that survey, and not just do that survey, find out what the conditions of that environment is, do a survey, get the survey report. With all this, you put it goes into the study, and the right method is chosen. For the dynamic position system, it's pretty much straightforward. Everything that we've written here, what are we trying to say? You The rig is there with thrusters, and you have a control system that communicate to each other. So there's a pre-plan telling you the kind of environmental forces that is going to hit you. And you also need to have a system that tells you where you are. So you're going to have transducers and you're going to have transponders, and it's a it's a pre-calculated design. So it takes in all this information, all this environmental information, and takes also the information where you are. So with all that calculation, so before the environment hits you out of position, and you also communicating with the system as in the feedback system, the transducer transponder communication, telling you that you should be where you are supposed to be or you are not. The thrusters immediately, the system immediately that has that address, if you are not where you're supposed to be, it powers up the system, sending information to the transducers, sorry, to the thrusters, and immediately it gets you back to the right address. So that's how it pretty much works. So it's pre-designed with all the information that you need, as in the northerns and easterns of where you are supposed to be, and that information is fed into the system. So the system has that address, it keeps it, and when the forces are acting on you, we keep there's constant communication confirming you are where you should be, and if you are not, the trusters respond accordingly to bring you back where you're supposed to be. So that's what all this is speaking about. Yes. So and like I said on the other slide, on this slide it's just buttressing what we said on the other slide. So you need two systems, two main systems rather. So one is the method of measuring your external forces. So you need to know your wind sensors to measure your wind speed and direction, and based on that, a technique known as the feed forward is used to predict the vessel response. Then second one is what measures your vessel position. So once you have these two systems, one tells you your position, confirming your position, then the other one uses the feed forward calculation to predict the vessel response and tries to respond immediately to get you back on location. So that's what this diagram is pretty much showing. It's kind of explaining everything that is being discussed here, and how finally it passes information to the thrusters. So you see the transducers communicate to the system and confirming where you are. Some way it goes to the power system, but finally all that information is passed on to the thrusters, telling you telling the thrusters move to this direction. So on that system, you have azimuthal thrusters that tells you where you should be per position. So when it passes that information to the bow and azimuthal thrusters, it brings you back to where you're supposed to be. If you are not, if you are, that communication continues. It lets you be where you're supposed to be. That communication continues, and immediately you're deviating or drifting away, it gets you back on location. So in telling us, don't forget, on the last slide we said we have a system that measures the vessel's position. So we're going to be talking about these systems, which is pretty much on the next slide. We have three of them, or I think about four of them, but here I've just described three of them. The long baseline system, that's the LBL, the short baseline system, SBL, and the super short baseline system. So sorry, just 1 minute. Yeah, and the super shop businesses, there are about, I think, four of them, but we pretty much discussed three in here because these are the methods that are widely used in the industry. So looking at them one by one, the first one, the short baseline system. So you have transducers connected to the rig, sorry, connected to the moon pool somewhere on the rig. Then you have um, the pinger, that's the transponder, perhaps where the wellhead is, and they communicate directly with the transducers, confirming that they should be where we are. So it's short, straight to the point. You have one transponder on bottom pinging to three receivers on surface, just communicating where we are, just trying to confirm when we are. The second one, so yeah, so this is just something bigger showing us where we are. So this is where the BOP should be perhaps installed on the BOP. Then you have the receivers here on the vessel. The second one is the long baseline system. For this one, the way it works is that you have about four transponders, maybe just deployed around the wellhead system or around the BOP. So you have a system just down there. Then you have one, you have a receiver on surface. So you ping, as you ping, it receives and it sends back. So all four seabed transponders receive that signal from the transducer and send that information back with their own frequency. So each of them have independent frequencies. So once you we and the a ping is sent from here, it goes all the way down, and we receive with this transducer on surface, telling us that okay, we should be where we are. Okay, the address of we know the address of this transponder, we know the address of this transponder, we know the address of this transponder, so we know the address of all the transponders. So the information is sent and it goes to and fro and we receive on surface. And this is what it looks like. So you have your transducer up here, then you have your transponders just around the wellhead system and the riser. So we just go ahead to ping and receive the information confirming where we are. Then the last one is the super short baseline system. It's just one on bottom, one on surface, one transducer, one transponder, sends, receive information, confirming where we are, period. And this is what it looks like. So one to one, and information is sent, get a feedback, and confirms where we are. And so when that happens, um, confirming where we are, if we are not, this is the next equipment that we will be that communication will that information will be sent to. So once we confirm that we are not where we're supposed to be, information is sent immediately to the thrusters. So for applications like the drilling floating unit, we don't just need the bow thruster, we also need azimuthal thrusters. Azimuthal thrusters have to do with positional thrusters. So they, regardless of the direction that you've drifted to, they get themselves on and move you back to where you're supposed to be. So they don't just move back forth, they also move in an angular direction. That's what the second line is pretty much telling us. So this is what the size of the thruster looks like comparing it to human. So sometimes on the vessel, just to show us how they are positioned and how they can be used to swivel and get the rig and or vessel back on location. Yeah. So here we have azimuthal thrusters positioned in different directions, helping the rig to quickly respond to whatever movement that we have and get it back on position. So, understanding the levels of dynamic positioning, we need to know that we have DP1, DP2, DP3. It increases going downwards. So, what do we mean? DP1 systems are very simple and used where we, not as if we don't want safety, but say getting the rig positioned or getting the system positioned isn't so critical. And you can usually find this kind of system in environments where the water isn't really bad, where the weather conditions are really calm. For DP2 systems, it comes with some sort of redundancy. And what are we saying? In the event that one system fails, we have another system just comes up immediately and takes over the system that has failed, and in that way we can confirm where we are at every point in time. DP3, like I said here, the gold standard, used in very high risk operation. You cannot afford to have any system go down. Your system needs to be functional all the time. So you have a system, it goes down, you have a backup, and the backup to that backup. So used with a lot of safety measures comes in mind when you have that kind of system. So the major difference is redundancy levels. Because DP3 has the highest redundancy level, followed by DP2, then DP1. Um, For safety protocols, DP3 has the highest. From power supplies to emergency drills that are performed on DP3, it's top notch. This is because of the safety levels you want to have to prevent an incident from occurring. The pros and cons of a dynamic of using a DPS. So for the pros are for safety, very useful in rough seas, and they can reduce the risk of accidents. Precision, top notch. For the underlying cables in DPS is actually a lot more better, as it ensures pinpoint accuracy, ensuring to get you back there to the address where you need to be. Environmental care, you anchoring is very rigorous, and not just that, trying to get the anchors seated on bottom, you pull test, sometimes they slip, and most times during operations you actually lose some of these anchors. And but with the DPS, you completely annul all that. You don't have that happening in your operation. And most especially when you use the DPS, you don't have, you kind of protect your seabed. In an environment where you have a lot of flow lines sitting on the seabed, you wouldn't bother using the anchor system. Your DPS gives you that opportunity to be able to drill your well, sit floating where you're supposed to be without dropping anchors on bottom and damaging flow lines. So DPS excellent in excellent for those kind of operations. The cons, when it fails, we all know anything electronic fails. When it fails and it feels bad. Um, I had a drill supervisor on the rig one point when I was on the Scarabeo 3. I think that was about 2011, 2012. He was giving me a story of how their DPS system failed, and before they knew what happened, they had drifted completely away. So it failed, and so some way the computer system didn't pick it up. They had drifted well away from the surface location. Luckily, they had not started drilling yet. I think they were still doing the riserless operation, I mean, about to commence the rescue operation, and or rather getting the rig accepted at that time. If they had, imagine that they had the riser latched onto the wellhead system, it would have been catastrophic. The costs are usually very high, of course, for obvious reasons. Then the skill is eroded. So imagine where all these very skilled guys are on the rig, where they would have been doing their station keeping, monitoring themselves, ensuring that everything is in place with the mod system. But now you're depending on computers. At some point, when you don't use these skills, I mean, using these skills and sharpening them as often as you should, you begin to lose them. So once very skilled members that you have on location, at some point, all that experience begins to erode. Thank you very much, everyone, for following us to the end of this video. Thank you very much for rounding this topic with us. We have actually come to the end of the fundamentals of subsea drilling operations. We will be moving now into drilling design in detail. So thank you once again for following us to the end of the topic. We'll see you in upcoming videos. Please do not forget to comment, do not forget to like, do not forget to subscribe. See you on the next video. Bye for now.